same workflow in Fusion and Alibre, roughly same time to do the same part. Hello guys and welcome. Now today it's going to be the first video of a new series called The Best CAD System You've Never Heard of versus, and we're going to start off with Fusion 360. Without further ado, let's get to it. The first thing I will be doing today is I'm going to make a pipe flange that is commonly found in large piping assemblies, like you would find in a oil and gas pipeline. And I'm going to this website called Marcel Forge. They have an absolute wealth of tables, right, where you can get data from, and I will be choosing the DN20 the DN2633 for pipes certified up to 16 atmospheres of pressure. And there you go. This is the table, which I will keep in my second screen, and I will draw a DN150 pipe flange. That's the 6-inch pipe flange for NPS. Right, and it is this line. Let me just briefly mention that you see you've got two values here, 168.3 millimeters and 159 millimeters. Well, what that is D1, which is outer diameter of the stud piece of pipe on the top of the flange. So that is what D1 is, and it is different between the ISO standard and the DIN standard. I'll be going with a thicker one today, which is 168.3. The rest is the same. And with that, let's get started with Fusion. I made a personal license in Fusion because my commercial one expired in 2021 when I stopped using it. Or was it 2022? But I made a new license and I just fired it up to make sure it works, make sure it switched over to my personal license. And immediately I found myself in this screen, and I have to say that's a nice dark mode, but you know, the UI and the beautification of the CAD system was never a weak point with Autodesk. So let's make a new part, and we have part design, assembly design, or hybrid design. Now that's interesting. So let's, okay, so I think I know what this is, right? These two are the more common. Oh, what is that? Sheet metal creates a component. Oh, okay. Yeah, okay, so what they've done is they've brought Fusion closer to what other CAD systems do, because maybe people were finding it hard to get into the mentality of Fusion. Fusion's strong point has always been the hybrid design, which gives it the strongest advantage that Fusion has, which is in assembly top-down design. So if I right-click here, I get a new component. Okay, so I see it's got hybrid design here, and I can change it. Right. So if I go to part, okay, convert. Sure. Okay. So, okay. I see what's going on. And we've got an AI assistant, and we will be discussing that one. You can be sure of that. Menus don't change. It's just that. Okay. Let's be. My God, this is annoying. Yes, thank you. Yeah. Okay. Let's make that pipe flange. I will have that line of dimension somewhere for you to see, right? So that you can follow along if you want. But basically, we will start off with the disk of the flange, and we will start off with a sketch along the XY plane. And okay, so it does say top here, but you see that unlike SolidWorks, Fusion shows X, Y, and Z axes by default. right? So this, looking down on the XY plane, is is marked front on the Alibre view cube. Here it's marked top, but it's still the XY plane, right? So I'll go for a circle C shortcut. Hey, muscle memory kicking in. And that needs to be 285 millimeters. Hey. Okay. So modify, change parameters. That's sketch one. There's our first parameter. Okay. And we need to extrude that for B minus F. Okay. So B is 22 and F is 3. So that is 19 millimeters. And that is our disc. Okay. Now let me make the raised face on the bottom, because that will help me get my dimensions a bit better, and that is D4. So D4 is 212, right? So that's 212. And I extrude that for F, which is 3 millimeters. And if I click here, hold shift, click there, you got two faces 22 millimeters apart, which is my B value, which means I'm doing well until now. Okay. And now I need my taper. Right? I need a tapered cone here, which I can do with an extrude. Sorry, D first, and this will start off as D3. Now D3 for us is 184. Okay, we've got that value there, and we need to go 55 to the top of the stub minus H2, which is 12, which is the length of the stub, but we were already 22 millimeters up. So we will extrude this from the profile plane that distance. So we will do this. We will say 55 minus 12 minus 22. And that needs to end up at a value of 168.3. So the taper, what is that? 4.8 degrees? Okay, so I could either loft it or I could do this with math. And doing it with math would mean, so I go from 184, I go to 168.3. So go inwards. I go inwards by 184 minus 168.3. Okay, so that's how far I go inwards. I use an expression there, so let's make this 5.5. Okay, yeah, that's rubbish, but I can go to my parameters, and that is extrude 3. So here it is. So no, I don't want that. I want this. This is my 184. Okay, so let me just make sure. Okay. So the name, this is going to be pipe OD, which is the outer diameter of our stub. And the expression is just this. Okay. So let's go back in there. And now we have D9 minus pipe OD. Yeah, that one. So this is the A10. D9. What is that? I wonder if it's even going to accept it. D9 minus pipe OD. Okay. And I'll divide that by the height, which is D10. doesn't like that one bit. So why doesn't this expression work? Oh, because I forgot this. Hey, 36.8. There you go. Well, that's interesting. Let me. I want it the other way. Okay. Hey, this is not bad. Okay. It's a bit more clunky than it has an animation. Oh god. Wait, that wasn't supposed to happen. Ah, yeah, I know why there's a problem there. So I need this again. Yep, that worked. Hey, that is excellent. Spot on. Am I still inside the sketch? No. Okay, so this is pipe OD minus 711 times 2. And that's what we will cut through. So we hit E again, because if I select to all, basically, profiles. Okay, yeah. Okay, so cutting and adding material is the same in Fusion. It's the same as in Inventor. You can still change it, the operation, whether it is cut, join, or whatever, but it is here, and you can choose to ignore bodies with your cut or whatever. Okay. Oh, cool, 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 cool. We are getting there. And now I can just click here and extrude, and it will extrude the face. So I will extrude this for 12 millimeters, and I'm okay with that. That's the profile of my flange. What we need to be doing now is the holes, right? Oh, wait. No, we've got, okay, that's 711. What is S? 4.5. Okay, so we've got the minimum thickness here. So that 711 value I found was wrong. So if I double click this, okay, so in Alibre you double click this and it opens up the sketch that made it. Here you go there. Okay, so this 711 value was wrong. This is 4.5. Okay. And we're just missing the bolt holes, which are D2 is 22 millimeters. Okay. So let's do, okay, so the reference is one reference, and this is the other one. And okay, so definitely the way I know how to do in Fusion, or rather I remember how to do in Fusion, is you make a point. I'm going to make a point of, yeah. So now I'll just select these two and I'll constrain it like that, and then click there and there, and I need to make this 120 millimeters. So now when I start the hole command, I can go there and just select the placement from sketch. Okay, so these remembers these. Okay, and to close out this entire thing, I need to give it a circular pattern. Circular patterns of features. There you go. This is the axis. Oh, well, we could say that this is the axis. 8 of them. Compute type identical or adjust. Ah, yes. I used to hate this. I'm not I'm not sad to not have to play with this anymore. That's our flange. That is our flange done. First of all, yes, thank you. Wireframe, no. Shaded. How did, okay, that's a lot better. That is a lot better. Okay, shaded, yeah. This looks like a flange. This looks like something you'd buy. That's great. So we did it. We did it in Fusion. Let's go do it in Alibre now. Okay, so we're back in familiar territory here. So let's go. This was 284. So that was 285. And that was B minus F, which was 22 minus 3. That was 19. Now we need to make the F, which is a small circle here. And that is a diameter K, which is 240. And it's 3 millimeters. And now I'm going to do the cone, and that started off from a 184. Right, and then I need to extrude it, and I need to do, so the overall is 55. Let's do it the same way we did in Fusion. So this is 55. Let me make a pipe OD value, which is this number. And now, oh, I didn't need this now. Okay, anyway, so that's 55. 5 minus 12 minus 22. Okay, now I have an angle here. Let's do 20 degrees inward. There we go. So here we're going to do A10, and we're going to say that this is D13. No, it's not D13. That is D12 minus pipe OD divided by 2. Okay, we have a dimensionality issue, but that will get fixed when we divide by D13. So 20.496. Fusion told us that that was 20.5, but you know, I mean, I assume it made it correct. So, oh, okay, let's do it the same way we did in Fusion. So let me check that this is actually the value that we're after. Okay, that's cool. That is now 4.5. And that's a tie tab move. Okay, in Fusion, we just clicked here and hit extrude, and it extruded it. That doesn't work in the extrude feature in Alibre, although it does work in the loft feature. So it doesn't do that in Alibre. What you do is you do my imprinting trick. That makes everything a reference. You hit Control A to select everything, B to make it back into solid geometry, and then E, and now you're extruding it. There you go. And now I hit H to open the whole wizard. So this is a 22 millimeter that goes through all. And I hit dimension. This is 120 millimeters. And this is also vertical with that. And we're done. And we do a circular pattern of 8 of these around. I can either do the Z-axis or, you know, any circular surface. And there we go. This is it with Alibre. So the actual workflow is exactly the same. It's not even faster or slower. If you, I messed up there, didn't I? So that's K. What? It wasn't K 240. K was 240, but K is, so I needed D4. Right. So D4 is D12, 212. Okay, 212. Here's a cool trick. Somebody asked in the forums, how can you close the sketch and go all the way down and not need to regenerate again and whatnot? So here's another cool trick on how to close a sketch and get to the bottom of the feature tree in one shot. Instead of hitting deactivate sketch here, you hit F5, which is the shortcut key for regenerate all, And what regenerate all does is it closes the sketch first. So I hit F5, there you go. I don't remember who it was that asked about this in the forums, or was it? It wasn't in the forums, it was in the last Q&A live, right? So there you go. That's another way to do it. You just hit F5. So that's our pipe flange. I'll just save it locally. All your files are local. So best CAD versus series, and I'll just save it here. Time-wise, it's probably the same. I was sightseeing my way around Fusion, if you will, because I hadn't used it in so long. But yeah. So there it is. Same workflow in Fusion and Alibre, roughly same time to do the same part. And just to make the point, we've got 1, 2, 3, 4, 5 extrudes, a hole feature, and a circular pattern. And in Alibre, we've got 1, 2, 3, 4, 5 extrudes, a hole feature, and a circular pattern. So not a lot of difference between the two software, except here. This is the difference, right? This is where the difference is. So I've made a table comparing the various features of all of the 3 Alibre design tiers and Fusion Base, which is the basic subscription you get with your account, and Fusion for Design, which is the design package. It's basic Fusion Basic with the design extension. And also note that if you want the advanced manufacturing tools, you pay for the manufacturing extension on top of this, which is like another 2,000, or the simulation is another 2,000. So this can get to an eye-watering amount pretty quickly. So let's go through this. I'll give you some important points here. So what you saw today can be done with Alibre Atom 3D. If I had been using Alibre Atom 3D, the workflow would have been exactly the same. I did not use a single tool that is not available in Alibre Atom 3D. And Alibre Atom 3D is $200 for a perpetual license. Okay, so that's an important piece of information right there. Secondly, the target user for Alibre Atom 3D is definitely the hobbyist, but also the professional that is not reliant on design, like a machinist or a woodworker, right? You can do that with Alibre Atom because Alibre Atom is a commercially usable product. You cannot use Fusion 360 free subscription for commercial use. So that's big right there. When I say here basic, Alibre Atom does not have the mechanical joints. So gears, pulleys, gear racks, you cannot assemble a mechanism that has these in there, but you can put the components in the assembly. Another interesting note here is weldments. Weldments are coming in June for Alibre. Famously, I go on about it every live, on every Q&A live session we do. I find a reason to mention weldments because I'm so excited about it that we'll be getting it inside the $2,000 perpetual license. Now we will also be getting weldments, which is amazing if you consider how much SolidWorks costs for professional. I think has weldments in it, but yeah, it's amazing. Fusion has the frame tools, which is something like that, not exactly like that. Another thing, PDM with Alibre Design Expert, inside the $2,000 price tag for the perpetual license, you also get a PDM system, and it's yours forever. The software and the PDM system. Whereas Fusion does do PDM, of course it does, but it's cloud-based and you don't own the files and all of that. Okay, PLM. So yeah, Alibre does not do PLM. Finite element analysis. I've done videos on how to get FEA when you're designing on Alibre. Generative design. You don't get generative design with your basic subscription of Fusion 360, which is rubbish because generative design is based on genetic algorithms, not AI, and they've been around for decades, right? Plus, there are free FEA systems out there like the Z28 solver that do topology optimization. That is what generative design is. It is topology optimization using genetic algorithms, right? Another point, rendering. Fusion does rendering, does it great, very nice. It renders in the cloud and you use tokens for it, which means that every month you got a very finite amount of renders you can do, and if you want a higher resolution render, you pay more tokens. Whereas with Alibre Design Expert, again, inside this $2,000 perpetual license, you get Keyshot. You get actual Keyshot, the actual rendering software Keyshot with it. You get a version that does not do animated renderings, but for static renderings, you do them locally. You do them on your own PC. And it works with ray tracing GPUs, and it speeds up the process immensely. And you do it, I mean, you do it locally. Alibre Atom does have Excel integration, which gives you basically configurations capabilities, because you do a VLOOKUP in Excel and you change the values, and now you do configurations in Alibre Atom. Fusion does have Excel integration, maybe. We'll look at that at a later date. All of this is interesting. Data ownership. Guys, this is what it's all about, right? You own your own data. I don't know if you've ever signed an NDA or a contract saying that you should not release the files to a third party. With Fusion, you're already releasing the files to Autodesk, and they've got this design assistant AI, and they're using your files to train it. So that's legally gray area. Alibre, it's all fully locally owned. And finally, I've got some pricing assumptions here. Now, this is interesting. You can read up on it and see, but what I want to draw your attention to is this. First of all, this is wrong. I did the math wrong, because in the full maintenance, I have the $2,000 purchase price, and then I have $2,500 of maintenance. That's wrong. For 5 years, you only pay 4 years of maintenance, because the first one's free inside this $2,000 perpetual license price. So 5 years full maintenance is $4,000. Compare that to Fusion Basic, which has a lot of shortcomings, and we'll explore some of those. And also look at this, Fusion for Design. It's almost $11,000, right? So for the same amount of, and this doesn't change, because you will be paying for that subscription over the course of these 5 years, right? Whereas let's say that you choose this, which is not 2 years of maintenance, it's actually 3. The first year that you purchase and 2 other random years that you decide to pay for the maintenance, that's $3,000 for Alibre Design Expert. So instead of buying Fusion for Design and getting 1 seat, what you could do is you buy 1 seat of Alibre Design Expert, $3,000, 2 seats of Alibre Design Pro, that's $3,600. We're now up to $6,600, and then 10 seats of Alibre Atom 3D. 10 seats of Alibre Atom 3D. And now what you have is your entire design team outfitted with perpetual licenses of the same software. You've got interoperability, right? And it's your entire design team for about $1,400 less than a single seat of Fusion for Design. So yeah, Fusion for Design, it's got more tools, great. But you cannot ignore this, right? You cannot ignore that for the price of 1 seat, you can outfit a 13 people design team perpetually, not for a year, not for 5 years, forever, right? And that's important. That's really important. That's the Alibre value proposition. That is what made me change over to Alibre. I've had to adjust a little bit. I have to give Fusion credit for being the absolute best in top-down design, but it's a slightly different workflow. It's not, you know, tragic. And I have been using Alibre for 5 years, so I'm roughly around this use case. And in that 5 years, I've had times where I've had a very, very tight cash flow. And would that mean that I would be out of a CAD system if I was using Fusion? Probably. So yeah, that's it. Anyway, more videos to come. Next videos will be spreadsheet integration. That's going to be interesting. And using AI to create actual 3D models in Alibre and Fusion 360. So subscribe to get notified for when those videos drop. Hit like if you liked this video, hit dislike if you didn't like it, and I'll catch you in the next one.